So, homework 8-1 Q&A, and this will be number 6, right? Find the arc length. Let's see, what is the language of the curve? L, and L is defined by y equals the square root of x minus x squared plus the arc sine. So let's write it sine like so, arc sine of square root of x. Okay, so this looks like a juicy problem here. And what Matt has an issue with is the fact that we don't have boundaries to speak of here. Did I read you correctly? Okay, so if you think about the boundaries, first of all, you have boundaries determined by the inverse sine. We know that the inverse sine exists for our intent and purpose between negative pi over 2 and positive pi over 2, including the endpoints. But also we have another restriction by the radical, as we don't allow the radical to be negative. So it means that x is less than 1. Okay? So one boundary will be x equals 1, the other boundary will be x equals pi over 2. Well, pi over 2 is greater than 1. Okay? What about the other boundaries? The other boundary, can x be a negative value? Well, no, because we'll have a negative. So the lowest boundary will be 0. So kind of force the issue that the integral has to be, or the curve exists between 0 and 1. And that's it. It has a starting point. It has an end point. So, so the solution are the endpoints of the curves. So let's write first. We need to determine the curves endpoints. Okay, so there are two considerations. And I'll start with the one that really does not apply. One is the inverse sine of the square root of x. First of all, the square root of x eliminates the negative pi over 2. So this will give us 0. And we can take 0 here, and we can take positive pi over 2, right? So that gives us another. And the second will be the radical, x minus x squared. Okay, this will give us x has to be greater than or equal to 0, and we can accept that, and we can accept 1. And since this is more restrictive, the second consideration is more restrictive than the first one, is pi over 2 is approximately 1.57, which is greater than 1. So therefore, the endpoints are x equals 0 and x equals 1. And now we can continue the rest of the way by using the arc length technique, using the arc length theorem. Do I need to show that, or this technique, this is not a problem?
I think I